Hi, let us see some properties of asymptotic notations. General property: if f of n is big O of g of n, then a into f of n is also big O of g of n. This means, example, f of n is 2n square plus 5, for example, and if I say this is big O of n square, then 7 into f of n will be 7 into 2n square plus 5, that's 14n square plus 35. When 2n square plus 5 was big O of n square, then 14n square plus 35 is also big O of n square. Actually, here we have written the degree of this one, and here also we can write on the same degree. So this is order of n square. So this means that if already for any function you know the big O function, then if you multiply that function f of n with anything, then also big O will be same. So this a is a constant, some constant value. So this is true for big O, and even it will be true for omega also. If this is omega, then also this is omega. And it is true for theta also. So the same property applies for all three notations. Reflexive property: if f of n is given, then f of n is big O of f of n. It means, example, f of n is n square. So this is big O of n square, that is f of n only. So a function is the upper bound of itself. Yes, it is true. Upper bound is any function greater than or equal to. Greater than or equal to. So that same function is an upper bound of itself. And similarly, this is for upper bound only I have shown you. Now if it is lower bound, then any function that is smaller or equal to forms a lower bound of a function. Right? So if any function is given, let us say, if it is just I am writing one term, okay, n square, then it is big O of n square only. So it's big O of itself. Yes, this is true. F of n is big O of f of n. And here one more thing, when I am writing here is represented using equal to symbol also. Next is transitive property. If you have f of n is big O of g of n and g of n is big O of h of n, then f of n is big O of h of n. Yes, this is true. Let us take example. I will try to write upper bounds. F of n is suppose n, and g of n is n square, and h of n is n cube. If these are the functions, then n is big O of n square, and n square is big O of n cube. Then n is big O of n cube. See, this is f of n, g of n, g of n, h of n. So here f of n and h of n. So when g of n is an upper bound for f and H is an upper bound for G, then H is also acting as an upper bound for F also. This is a simple thing only. So transitive property satisfies on asymptotic notation for all three notations. I am showing only one notation, that is big O. It is true for omega and theta also. Now symmetric property. If f of n is theta of g of n, then g of n is theta of f of n. Now symmetric property is true only for theta notation. Example, f of n is n square and g of n is also n square. Then f of n is theta of g of n, that is n square, and g of n, that is theta of n square, that is f of n. When both the functions are same, then they are symmetric. One is theta of another and that second one is a theta of first one. So both, right? First one is theta of second one is the theta of first one. So this is true only in case of theta notation. Next is transpose symmetric. This is true for big O and omega notations. If f of n is big O of g of n, then g of n is omega of f of n. Example, let us take, if f of n is n and g of n is n square, then n is upper bound n square and n square is lower bound n. So for n square, n is lower bound, for n square is upper bound. So these two are function, n and n square. So one is an upper bound for another and vice versa, that's one is a lower bound for another. Right? So this is true for upper bound and lower bound. So first I have taken upper bound, so then lower bound, you change it. This is lower bound, then that is upper bound. So if one function is forming an upper bound for this one, then this function becomes a lower bound for that function. Now there are a few more things. If f of n is big O of g of n and f of n is omega of g of n. So this means that there is one function g of n which is acting as an upper bound for function f as well as lower bound for function f. Then definitely, so if function f of n is here, then f of n is here and this is acting as a lower bound as well as upper bound. So when you have g of n on both the sides, same g of n both the sides, then therefore f of n is theta of g of n. Yes, when the same function is both upper bound as well as lower bound, means actually it is equal. That's how it is coming in upper bound as well as it is coming in lower bound. So in upper bound we take equal or greater. Lower bound also equal or greater. If something is appearing in both, means it is equal. So that is theta bound. Next, let us take one problem. If f of n is big O of g of n and d of n is big O of e of n. There is one function f of n, upper bound is g of n. There is a function d of n, its upper bound is e of n. Then f of n plus d of n, what will be the answer? Let us take an example and check. Example, f of n is n and d of n is n square. Then for this one, big O of n, and for this one, big O of n square. And if I write f of n plus d of n, then what this will be? n plus n square. Then what will be the answer? This is big O of what? Big O of what? The greater term is n square, so it will be n square. Now as per my example, here I have taken this as n and this as n square, so n square became the answer. If suppose this was n square and this was n, then this n square will become answer. If f of n is n square, if this is square and this is n, then again the answer is same. So it means the answer will be the maximum of these two terms. Whichever is greater, that will be the answer. So yes, then f of n plus d of n is big O of max of g of n comma e of n. G of n comma e of n. So for f of n, if you have a big O, for d of n also if you have a big O, if you add these two, then which one will be the answer? Next, if f of n is big O of g of n and d of n is big O of e of n, then f of n into d of n, what will be the answer? They are multiplied. So directly I will write, if suppose this is n and this is n square, then product will give you n cube. So yes, this is big O of product of this one. So product of these notations, g of n into e of n. This will be equal to big O of g of n into e of n.